Good morning. I'm Pete Barber. I work with VeriSign. We're going to be talking about traffic source analysis for JRoot anycast instances. So if we go back to the history about what kind of analysis was done before we started doing this on root servers, there wasn't a whole lot of research that was done beforehand, and we had some people openly question whether we should be using anycast for root servers. After we started anycasting, some people within VeriSign, Mark Hosters, Matt Larson, and myself, put together a presentation called Life and Times of JRoot, and that was part of NANOG 32. Within that presentation, we analyzed the data of some of the JRoot sites that we had at the time. I think we had maybe 8 or 9 at the time. We analyzed the data in different ways, and we found some interesting things. That most of all, we got a lot of non-priming queries to the old JRoot, which we still really haven't been able to fully explain. And the second part of that is that some of the IP addresses we saw were at more than one site, and sometimes in very rapid succession. So we're going to really focus on that second thing that we've discovered within the first presentation. Some other people did some analysis about root server anycast, and there are some other very good presentations out there, most notably ones we'll list here. Peter Booth and Randy Bush put together a presentation about highlighting anycast instabilities. And what they did is they had a whole bunch of volunteers run TCP and UDP probes. And when the conclusions came in, they found that there was some routing weirdness, and TCP and UDP probes had different failure rates. Most of the people who did this were all volunteers, so we think that the sample base was a little wrong. This doesn't necessarily mean that all the people who were doing the data analysis and the collection were volunteers, and they're a little more clueful than some of the people at the edge of the internet. So we think that the sample was a little biased that way. Another presentation was DNS anycast stability done by Daniel Karabberg. He looked at the DNS the write monitor from 77 different sites around the world. And again, this is another one of the situations where the sample base isn't really representative of what's out there in the internet. Lorenzo Coletti put together a presentation called The Effects of Anycast on K-root Performance, and his analysis included stability and its effect on its performance. And some of the things he found was that 1% of the unique source IP addresses switched the sites, just like some of the stuff we've seen for JRoot. He also only did 5 hours worth of analysis of the data, and we've tried to do a full day's worth of data collection. Another presentation was Operational Experience with TCP and anycast by Matt Levine, Barrett Lyon, and Todd Underwood. They made the conclusion that there was no real problem with TCP and anycast. So you might be wondering why we're doing this presentation if there's been a lot of work with this before. And we're not trying to throw stones at the other people's projects at all. In fact, we're just trying to add a little bit more information to the total question of anycast for root servers. And we want to do a follow-up with our own analysis with more data. So for this presentation, we put together, we collected information from our, at the time, 19 anycast instances. Now we've got 25, but when we had this, when we did the data collection, it was only 19. All of the JRoot instances are sourced out of AS26415. We have a mix of global and local instances. And when we say local instance, we just mean it's peering only or upstream route filters. The JRoots do have a mix of transit and peering. For this presentation, or for the data collection, we did 2 separate data packet captures. The first one was for UDP, and that was inbound only. That did not measure anything fun like a TC bit being sent out in the DNS response. And the second one we did was for a TCP bidirectional packet capture. Each one of these was for about 24 hours. They were not overlapping. And we did our best to make sure that every active anycast instance was represented in the data collection. So when we did all this collection, our goal was to answer these 3 questions, and we've actually had more questions come up since we did the analysis. So what kind of distribution of the source addresses will we see across all of these anycast instances? And can we explain the type of data that we're seeing? And can we determine if the data that we're seeing is causing a problem or not? With the UDP packet capture, it was about 26 hours, starting on the 25th and ending on the 26th of October. And we did a staggered start and stop for each site. It was hard to get all the TCP dumps to start at exactly the same time. Our high-level statistics is we had 335 million total queries, And that's actually not the total amount of queries we had. We had a little bit of gap of data that was missing from our Amsterdam site. Throughout the day, JRoot will take about 8,000 queries per second on average. So the next few slides we'll be having some complicated tables, and let me explain all the columns in the tables first before we go to those slides. The first one is going to be the source IP address. It's obvious that the client who does the query to the JRoot instance. The second one is going to be transitions. So this is a circumstance where we have the query bouncing between one anycast instance of JRoot or another, and every time it is seen on the first instance of that JRoot anycast and then seen on another, that's counted as one transition. The sites is the total number of anycast instances this client has been seen on. And the simultaneous seconds, if you take the TCP dumps and truncate the milliseconds and only look at every 1 second bucket, that's what we did for this, and that's what we considered as a simultaneous. So two servers talking to two different anycast instances of JRoot within the same second is considered simultaneous for the purposes of this. The total number of seconds is the total number of seconds that any of the instances receive traffic from this address. And the simultaneous is just a ratio. The specific sites, we'll use the decoder ring on the right side here. We have the 19 instances that we had during this analysis time, and you'll see the letters listed out. So we also faced a difficult question whether we were going to mask the original source IP addresses or not. So the addresses you're going to see in this presentation are true, and we're not going to hide the IP addresses or anonymize them or anyway. We're not trying to point these problems out or make fun of any providers or name server operators. We just really want to know what the original reasoning was between the hopping around. So if you see any of these addresses that you recognize, please get with me after the presentation and we'll go over. This is the table. This one is sorted by the percent simultaneously. You'll see the first one up there doesn't have a whole lot of activity to the site, so it's not really that interesting. But out of all the activity that it did to this JRoot cloud, we had 50% simultaneous. If you're wondering about the distribution of those top 30 addresses, we have them distributed all over the world, so it's not one particular region which is prone to do this. This is the same data but ordered on different columns. This one is ordered by how many sites, how many different JRoot anycast sites one of the clients has talked to. And we have, 25 sources here who've talked to 4 different anycast instances of JRoot within one 24-hour period. And you'll see some of these guys, like the first one listed here, had 93 times that he moved between one JRoot anycast instance to another. And that only works out to about 0.2% of the total traffic he did to us. So listing out the 30 most sites for geographic distribution for this graph here, you'll also see that it's distributed all over the world and not particularly one region or the other. This is the same data again, this time sorted by the number of transitions. The top one on here did 13,492 transitions. That means that it went from one JRoot server to another JRoot server 13,000 times within a 24-hour period, which is pretty significant. And that was only 9% of them were simultaneous, but we'll see that there was a lot of activity. This is a histogram here. It's a 2 log scale histogram of all the traffic that we see. If you go back to this slide back here in the beginning, high level statistics. This is of the total list of all the addresses that we saw here. So you'll see that we have a very small group of people who are doing a lot of transitions to us. This is the, if you look and see the, we have 1,000 sources here who've only done one transition throughout the day. So everything really gets interesting from the left side of the graph to 0, where we have a few people doing an awful lot of transitions. This is a geoplot of the 30 most transitions of the sites that did the 30 most transitions between 2 anycast instances or more. And this is a distribution of all the 5,600 source addresses which contacted more than one JRoot instance within one day of analysis. You'll notice that these plots are all over the world, and there's no particular region that they're happening in. So what we did is we plotted all these out, and then we looked at them, and we picked out which ones were interesting to us, and we're not really looking at the data, but looking at the plots, and you'll see the plots in the next few slides. We only looked at the sites that had queries from a given IP address, and amplitude indicates that the query volume was at this instance. The first two graphs are the type of transition that you would normally expect for an anycast instance, and this is one of them. So here we have a client here doing queries to the anycast instance of Dulles, Virginia, up until about 8 p.m. UTC, and then they do one transition to the site that we had in Mountain View, California. And this is a similar. We have somebody who was talking to our anycast instance in Amsterdam, and then around 4 a.m. UTC, they made the transition to Miami, to our anycast JRoot in Miami. So you can see that there's, we also plotted out some of the ones which were more simultaneous. You see the one who's basically ping-ponging between Tokyo and Mountain View. And the times that he's talking to us, he's switching back and forth between Tokyo and Mountain View. This is one of the clients who's doing a low amount of traffic to us, but you can see that there's several transitions. There were, in fact, 14 simultaneous transmissions. So that means that each one of these queries, there's not 14 on the top one, on the one in Seoul, but there are several times when it was talking to a JRoot instance within the same second. And this is another one of the lists where we have somebody who's doing a lot of simultaneous queries. This client was hitting Amsterdam and Dulles, Virginia at about the same rate through the first part of the day. And then later on, after about 4 a.m., he stopped hitting our Dulles site and was only hitting the Amsterdam site. This is one of the more pathological situations. We see one of the clients querying both of the JRoot instances in Atlanta and Seoul. I guess that's, yeah. Throughout most of the day, they were hitting, ping-ponging back and forth between the two of them, and most of them were simultaneous. There were 5,000 simultaneous hits. And another one of those graphs showing someone who's doing a lot of simultaneous hits between the Amsterdam and the Dulles site. So this is one of the situations where we see someone who's making multiple transitions. We have someone who started at Seoul, then went to Amsterdam, then went to Tokyo, up to Singapore for just a second, and then back to Amsterdam, then down to Seoul. So this was sort of an A, B, C, D, E, CBA type of transition. And we have the people who do very little traffic to us with 4 separate transitions. And this was one of the situations where there were very few simultaneous hits, but many transitions, so it was a ping pong. This was one of the more pathological situations here, where we saw a lot of transitions with very few simultaneous. So after we did our UDP analysis, we did a TCP packet capture, and we captured about 25 hours of TCP packets. Out of the high-level statistics, we captured 6,000 DNS responses we sent out of 238,000 TCP connections established. And of them, we saw 22,000 unique source IP addresses. So we did look at the resets, and we wanted to find out what the source of the resets were. And some of the reasons that a JRoot server would give out a reset were perfectly expected, like an idle connection. So we did count the number of resets that we had that were not preceded by SYN from the same IP import. And of that, we found 9,000 unmatched resets, which we don't really have an answer for yet. We saw resets to 5 different source addresses from 2 different sites. So why did we see so many resets? That we didn't really have time to make that part of the analysis. We do have to make a next presentation about why there's so many resets. That's a very interesting topic there. The real question is, why are we getting any TCP queries at all to JRoot? If you're familiar with DNS, most of the activity to a root server, in fact, just about all of it, should be UDP and should not be falling back to TCP. So we came up with a couple scenarios to try to explain this. And either the root servers are sending TC bits, or the resolvers just decided to use TCP and they continue to use it. Our 26-hour UDP packet capture was only inbound, so we couldn't really measure the number of TC bits that we sent back, but I did a 500,000 inbound query and matched them with the outbound, and we saw 4 TC bits being sent out. So it's clearly not a matter of the TC bits that we're sending out. Most of the activity we saw on TCP was all just people who wanted to use TCP, and there was no other rational reason we could come up for. Of the TCP queries that we saw, they were overwhelmingly type MX. They were what we think probably spammers trying to connect to the root servers directly to get their answer faster. We don't really know. We haven't really done an analysis on the clients. A lot of them were behind firewalls and weren't able to do it. We really highly suspect that this TCP querying without UDP first. We don't really know why. We'd really like to know. If anyone has any details about DNS clients that start with TCP and continue to use TCP, we would really like to know about that. So some of the conclusions we found here is that most of the interesting multi-site traffic looks explainable by per packet load balancing. And we do have some uncomfortable questions which came up with the unmatched TCP resets that our JRoot server sent out. Some of the iterative resolvers just like to use TCP and they prefer to use it, and that was the vast majority of the traffic that we had to JRoot that was TCP. And it looks like the analysis for TCP DNS over anycast is not exactly the same as unicast. We haven't really been able to find any legitimate traffic contacting the root servers that was using TCP. We don't really think that there's a problem here because the TCP connections to us don't really appear to be correctly formatted anyway. But we'd also like to do more research about that. And for the record, we'd like to point out that our first presentation, it did have this statement in it, do not run anycast with stateful transport. But I'd like to emphatically say that what we didn't say is don't run DNS over anycast. And we really believe in anycast. We have a lot of them. We have 25 sites for JRoot right now running over anycast, and one of the ComNet name servers is also anycast. BGTLD servers net is anycast. And we don't really see TCP DNS as being broken by anycast, and we think that it clearly works in most cases. However, we will note that longer running TCP sessions will probably have the route slipped out from underneath them, and we see that over the transitions for some of the clients that contacted JRoot during that time frame. And per packet load balancing sites will probably have issues with TCP anycast. So further research we'd like to do in future endeavors is to find out the reasons and circumstances surrounding these unmatched TCP resets. It really bothers us, and we want to find out what the source is with that. And we would like to know why people are doing TCP queries without being preceded with UDP queries. And we'd also like to do more investigation between our global node versus our local node context. We'd like to see if some of the traffic in the local nodes is leaking out to the global nodes or vice versa. And that's all I have for this presentation. Any questions?
Hi. I'm not surprised to see...
Excuse me, when you ask questions, can you introduce yourself and state some affiliation for context?
Yes. Chris Woodfield, Internet. Sorry. I'm not surprised to see a couple of flips between, like, for example, North American cities, like Dulles to Atlanta and back. That kind of seems normal to me. What is interesting is seeing people flipping from source IPs flipping between, say, Dulles and Amsterdam. I was wondering if you've done any sort of geolocation or logical location analysis of the source address that are flipping between servers that are that geographically diverse to see where exactly they're coming from. I mean, are they in a location that's a similar enough distance from both that a topology change wouldn't explain that? Okay,
well, since you opened the door saying you're for InterNAP, we'll say that the Atlanta site and the Dulles site are both using InterNAP. So yes. There's obvious reasons why that sort of hopping around happened. As for Amsterdam and why Amsterdam always showed up as one of the guys that was hopping around, it is a very well-paired connection that we have at Amsterdam. So that partially explains it. Have we done any geolocation for that? That sounds like an excellent next topic, and I'll write that down because it sounds like something that would be very interesting for me and probably other people in the audience here.
Got Mark Costers lurking in the corner wanting to say something desperately.
So we actually did geolocate those the top speakers that were kind of interesting in this case. So if you look at it, what I would expect to see is that from areas that didn't have a lot of bandwidth, that you would have a lot more per packet load balancing situations actually occur. And you would see a lot more of those sort of issues in the areas that didn't have high bandwidth. And what we found in this time around is that many of these were actually coming from the States, which I found very interesting.
Okay.
I've got a couple of questions. I'll ask one and then let somebody else.
Presumably you'll do that after stating your name. Yeah.
Brian Dixon from Affilius. I was wondering if in the simultaneous calculations you adjusted for the round trip times from the locations, the JRoot instances, and the origin.
I don't think that we really found a correlation between round trip times and the number of AS hops.
I meant in terms of before you did the simultaneous calculation, did you subtract off the actual round trip time since?
No, we just that would be a little bit too much, so we just truncated the numbers and
because that may be what
if it's
you're
close
seeing.
enough. Yeah, you're right.
Okay. In the middle. Good.
Oh, I'm next. Danny McPherson. So I actually ran your list of top 30 through, an AS lookup just to see what, and I figured I would see a couple of obvious folks there. I was actually surprised that there was a pretty wide distribution and nothing stuck out, like, somebody that might, play, particular tricks or other things other than like IBM event services, prefix. So I don't know, an AS distribution and the GeoIP stuff I thought was a pretty clever idea. On the TCP resets and also, I'm sorry, the spurious resets, I guess you're seeing, it could be folks looking to mitigate attacks and do like source authentication, and they say, if they receive a UDP query, then they hold it off and see if the source was true by, sending a reset by that, or or the TCP bit, where some people say, I'm not accepting these UDP queries from these sources anymore, I'm going to force TCP transfers, and then they proxy those sort of things. So those two kind of models, I haven't looked at the sources across that, but I suspect that either or both those may help address some of your queries. I'm not sure what percentage of the total, that made up. So there are enough people out there playing those kind of tricks today that, it might have an impact on your data set. So
Now I'll ask you a question. Do you know of any papers which describe that? I'd be really interested to read about
yeah,
that.
I know of several, so I'll be happy to send you an email on that.
Okay, great, thanks.
Scott Lyrand, Internet. Wondering if you've done any trace routes to the simultaneous querying sources to see if the source IP is actually in two diverse physical locations. Perhaps someone's doing anycast and is then doing DNS to your anycast nodes.
That's a good question.
In addition to the geolocation, it'd be interesting just to see if this IP address is the same server from both nodes, or if it's actually two different physical servers with the same IP.
No, I wish I did now that you bring that up. That sounds like it would have answered some questions.
Like Michael Richardson from Accelerants. I'm curious, I know root operators are often complaining about the large amount of garbage that they get in queries, and I was actually surprised at the number of continuous queries from some of these weird sources. And I'm wondering if you subtracted any of the garbage stuff from that, if you still get such continuous use.
Oh yeah, we get so much garbage on JRoot. It's if I ever want to get depressed about how people mess up their DNS so badly, I just look at all the NX domains JRoot gives out, and that's a whole nother subject.
So in your queries, you don't actually have the whole use. You have at least the type there. Are you able to go through your data and subtract what you consider to be garbage requests?
No, we lumped them all in, good traffic versus bad traffic. It really requires a sort of a human eye to figure out if the traffic looks like
I
a
was just
normal
really
one.
curious why there was so much traffic from any of those nodes to the root name servers at all. Thanks.
Follow up to the one question ago, fellow who was asking about simultaneous queries from possibly anycast instances. Have you also looked at the possibility of hijacked address space, where two different parties are using the same address space in disparate locations? I mean, that's one possible.
That is one
reason for
possible
some-
explanation. That would explain it. But that we did look at that briefly, but I don't think that we found any correlation. Yeah, it'd have to be a lot of hijacking.
Yeah. One other question is regarding the per packet load balancer. Have you made any efforts or investigated at all announcing the prefixes at different locations, anycast locations, with different BGP origin attribute values to break the ties?
The answer to that is yes, and Mark will tell you.
Actually, with each of the interesting graphs, to answer your question, we didn't do anything with BGP. So, but one of the things that we did do is we did contact each of those interesting IPs that you saw that were interesting graphs. We contacted each of those guys, find out, okay, what are you doing? And the ones who did come back and said, oh yeah, we're doing per packet load balancing. Is that, it works. But we showed them this behavior and said, hey, this may break some other stuff later on, but just be aware of that, so they are aware of that in the future.
Hi, Dwayne Wessels from the Measurement Factory. The TCP before UDP could be explained by something recently on the NANOG mailing list, which is that SSH port forwarding does not work for UDP, but it does work for TCP.
But would that explain the MX queries that we saw as part of
No,
it?
I think those are clearly spammers. Yeah,
I'm glad someone agrees with me on that. I guess that's it.
Standby explanation.
Yeah, that is. It's always good standby. I guess that's it.
Any other questions? Thank you very much.
Thanks.